Okay, so I've already done letter B and letter D. I was into the video and then the video just shut down on me, so here we are. This is a pretty simple one. Division equals subtraction, and that's all you do. This one, a little more difficult. Division equals subtraction, so I split that here, that goes here, and then the fun begins. The 2 just jumps in the front, but the square root of x is the same thing as x to the 1/2 power, because there's an invisible 1 there and an invisible 2 there, and you can write it as x to the 1/2 power, and that allows you to bring that 1/2 into the front. So that's the desired answer. That's how you expand it the most. And so keep an eye on that. Use law 3 as much as you can. All right, so we have an investment problem. Here's all your formulas that are exponential expressions. Here's your basic one. And then here's your actually life application investing, if it's once a year, multiple times a year. And then this is compounding interest continually, which I don't know if that'll be something we have to worry about. But James invests $15,000 into an account earning 3.1, so there's my R, there's my initial investment. Compounding quarterly, which is telling us to use this formula right here. How much money will James have after 12 years? There's my T. So we're going to use this formula right here. So how much money will he have? 15,000. 1 plus R. 3.1, we're going to convert that to 0.031. Don't forget that. Quarterly means 4 times a year, and then 4 pops up again, and then 12 years is the time. All right, so I'm not going to waste your time plugging things in your calculator. I think you can, but I'll show you a little bit of work in a minute. So I do want to show you guys something. I got 15,000. Now if I went like this, times 15,000, I'd get 21728, $21,728. If I round it a little bit, you're going to be kind of surprised at this, I think. 15,000 times 1.448. Yeah, $8. So not that exciting. So whichever. So we'll go with the original one because it's closest. $21,728, and we'll just call that 31 cents. All right, there we go. Next problem. If James invests the same amount of money, so that means this equals 15,000 when we plug it in, with the same interest, so that's 3.1%, for the same amount of time, but it's compounded continuously, how much money will he have? Well, the amount is what we're looking for. The investment is same. E is 2.71. I don't think you want to round that because that does make a big difference. Maybe that's what I was thinking about. And that's 0.031, that's the rate, and then the time is the same amount of time, so times 12. All right, again, I'm going to shut this down, be right back with you. All right, so there we go. Just multiplied that out, and then I got e to that power, gave me that, times that gives me this. So see me if you have problems plugging things in your calculator though. All right, Sherry invested $10,000, so that's her original investment for 9 years time, and it's interest compounded weekly. Now here's a twist. That's 52 times. There's 52 weeks in a year. If she had 12,520, so now they're giving us the actual answer, what it grew to. So this is a little twist on the formula. So they're going to mess with us a little bit. And the original investment was $10,000, but we have to use that crazy formula. Gets a little wild. 1 plus, Sherry invested, compound, if she has at the end, oh, what is the interest rate? So I was a little lost there, but they're asking us to find the rate, so rate. And we know the number of times is 52, and that would be 52 for 9 years, so this is going to be wild. 52 times, that's what that little n is, and then that t is 9 years, so that's 9. Just big old numbers, and what are we going to do? Well, don't you dare distribute this through. because we haven't taken care of that exponent yet. So what we're going to do is divide both sides by 10,000, divide by 10,000, and let's clean this thing up a little bit and then we'll talk. So, well, let's just do it. 12,520 divided by 10. I'm sure I could have just moved the decimal. 12.52, so we get, this is where the fun begins. 12.52 equals, look at this, 1 plus r over 52 to the 9, that's 450 and 18, 468, I think. I don't trust myself. So 9 times 52, 468. All right. So what do you do now? Well, we got to find this. Well, does that mean we got to raise this to the 468th power? Heck no. Slap a log on it, slap a log on it. Let's let math be math. So, log of 12.52, log 12.52, I'm just going to call that 1.1 just to keep things a little simple. And then what do we do with this? Well, we bring that into the front, so we get 468, hope I can remember that, times the log, this is going to get wild, of 1 plus r over 52. See, we can't turn that into a number because there's no number in here. So we got to divide by 468, divide by 468. This is crazy. So 1.1 divided by 468, 0.00235. I'm going to keep it there. 0.00235 equals the log of this crazy 1 plus r over 52. What the heck do we do? Well, there's a 10 there. Base, exponent, answer. That's how we get out of this logarithm. So I'm going to go 10 to 0.00235, 1.0054. 1.0054 equals 1 plus r over 52. That's just the way this logarithm's working. So we're going to subtract 1, subtract 1. I know I'm all over the place, but that would give us 0.0054 equals r over 52. Now I got to multiply by 52, multiply that by 52. We're going to finally find the rate. So 52 times 0.0054. What a math problem. 20.28. So 0.2808. All right. Which, let's see. Okay. So we're going to stop right there and move forward. Number 9. The half-life. Now there's so many different ways of thinking of it. That means things are being cut in half. The way my brain works is, if you have an initial amount, which is A, or the initial amount, and I want to cut this number in half, that means B has to be a half. Some of you say, well, R is equal to negative 0.5. You're not wrong, because if I popped it in here, 1 plus negative 0.5, that would create a 1/2 in there. I like to just stick with this. So ZN71 is 2.4 minutes. So what we're going to do is, because they're giving us this, I'm going to use this formula, but I already know this is 1/2. So if one had 100 grams at the beginning, so they're telling us start with that. So we know, here it comes, 100 grams at the beginning. I know it's got to be cut in half every 2.4 minutes. Now this is where it gets a little interesting. How many grams would be left after 7.2 minutes? So I can't just put the T there. If I just put the T there, it's wrong, because that's saying after 1 minute it gets cut in half. So I got to fix this by putting it over 2.4 minutes. That's tricky. But think about it. If I put 2.4 in for t, 2.4 over 2.4 is 1, and that's 1/2 to the first power. Then I can take half of 100 after 2.4 minutes. So here's our formula that we start with. Then we can let t be 7.2 minutes. So it's 100.5 to the 7.2 over 2.4 power. All right, so what I'm going to do, I think that's just 3. It is. So it's 100.5 to the third power. So I'm going to go 0.5 to the third power times 100, and I get 12.5 grams after 7.2 minutes. Okay. You pause that. All right. They're kind of hitting you hard with some story problems here, but this is it. Last problem, I think. And we can be done. But here we go. The amount of seagulls on the beach are growing exponentially, and you got to read math. What they're saying is this is going to be used heavily. Notice it says after 4 hours, there are 850 seagulls. If your brain can go, there's my X, there's my Y. Now we're talking about these problems that you guys didn't like so much right here. That's all they're doing. They're just giving you a story problem with seagulls and seeing if you can make the connection to this. So with that in mind, if you had a little picture like this, after 4 hours, so 1, 2, 3, 4, there's 850. After another 2 hours, so out to 6, there's 1350. And you can see there'd be like this thing going on, although you couldn't have negative time. So I don't want to mess with you or anything like that. But we're going to get started here. There's an X, there's a Y. So we're going to go 850 equals A times B to the X. There's my X. And we've got 1350, that's my number of seagulls, A times B to the 6th power. Okay. So now, we got that little variable A sitting there, so we're going to divide by B to the 6th, divide by B to the 6th, divide by B to the 4th, B to the 4th. So I get A equals 850 over B to the 4th, and I get 1350 over B to the 6th. So, notice the question, though. I didn't even read it. It says, how many seagulls were there after only 2 hours? Well, we're going to build an equation, and then we're going to calculate it using this formula. So, now I'm going to multiply this by B to the 6th, multiply this by B to the 6th. These cancel, leaving me with B squared. So we get 850 B squared equals 1350. Divide by 850, divide by 850, and here we go. 1350 divided by 850. I get 1.588. So B squared equals 1.588-ish. So now I need to take the square root of that, 1.588. I don't know what I just did. 1.588, 1.26. So B is 1.26. Remember, if it's growth, B is greater than 1, so that confirms our suspicions. And we're doing something. So now we know our equation is going to be y equals A times 1.26 to the x power. Okay. And, all right. So now we're going to find A by plugging this into our favorite equation, which is probably right here. So we're going to go 850 equals A times 1.26 to the 4th power. So I'm going to raise that to the 4th power, and I get 850 equals 2.52A divided by 2.52. So 850 divided by 2.52, and I get 337. All right. So I popped that 337, that 0.3. But that's my initial amount, so this should be rounded probably to the lowest amount. So y equals 337. I'm going to round that 1.26 to the x power. Give me a second. Okay, so what I've done is I've taken this 1.26, there's my time, 2 hours, and I put it in here, so 1.26 to the second power is right there. Then I multiply that answer by 337, and then that's the how many birds there were after 2 hours, and it kind of makes sense because after 4 hours there's 850, so after 2 hours there should be quite a bit less, and there is. Alright, give me a second. I'm not quite done with the video, but I might be. Alright, I was considering a whole different idea, but I think we're just going to say nope. This didn't even work anyways. I was wondering if we could use slope at all, but you know, you can't really use slope in an exponential situation to actually calculate this. So anyways, let's act like I never even had that thought. Yeah, tough little problem there, number 10. So work hard, come and see me if you have questions, and yeah, talk to you soon.